so this first example that we have, our angle is in radians. It's got pi, so we're going to use the radian formula, S equals R times theta. So all we have to do is take our radius of 18 and multiply it by our angle, 13 pi over 12. Now there are two ways that you can see this answer expressed. They will either express it in exact form, meaning they do not multiply out the pi. You put everything in this expression, 18 times 13 divided by 12, you just don't put the pi in there. So 18 times 13 divided by 12, 9 times out of 10 is going to be a fraction, so you might as well do math, enter. And that gives us 39 over 2. We left out the pi, so we just put the pi back in the numerator. So that is the exact answer. They may also put the approximate answer, the decimal answer, so then you do actually multiply the pi. So our approximate answer is 61.261. We did have units in the original problem. It said that the radius was in feet. Arc length, it's a linear measurement. We're just talking about the actual length here. So it is in feet as well. So you could see the answer expressed in either of those two forms. Okay, let's do one with degrees. Again, we did this a couple of weeks ago, but just reviewing it, you put, well, let me write it in general form first. You put your angle over 360 and you multiply it by the circumference. Remember, if we have the radius, circumference is 2 pi times the radius. So specifically for this example, our degrees or our angle is 300 over the total of 360 times the circumference. So 2 times pi times the radius of 11. We're going to do this one the same way. We want the exact answer, so we don't multiply out the pi. We multiply everything else. 300 over 360 times 2 times 11. And it's going to be a fraction. So 55 pi over 3. Okay, so everything but the pi, and then just put the pi in the numerator. Or the approximate answer, multiply out the pi, approximately 57.596, and this is feet. Now, obviously, the exact answer has the same units. I'm just going to write it beside the decimal approximation. Now, let's think about this for a second. Make sure that it makes sense. Okay, the arc length here is a portion of the circumference. We're talking about this part of the circumference. So if we found the circumference of this whole circle, let me look at the one on the left first. Circumference is 2 pi r, so 2 times pi times the radius, so it's 36 pi. And let's get the approximation there, 36 pi. The whole circumference is 113, we'll say 0.1. 113.1. Look at the diagram. Our arc is a little bit more than half of the circumference. The arc is a little bit more than half of the circle there. So it makes sense that our answer is just a little bit bigger than half, which is 56.5. Okay, so pointing that out, because if you have multiple choice answer choices, think your way through it. You should be able to eliminate some answer choices that don't even make sense just based on how much of the circle you're talking about. So let me look at it again with this one. 2 times pi times the radius, so that's 22 pi. So the whole circumference over here, it's going to be 69.1. This one is almost the entire circumference. So the answer choice of 57.6 makes sense because it's the majority of the circle there. Okay, so it's not foolproof, but I'm just trying to get you thinking of the fact that you have some critical thinking that can help you at least narrow down the answer choices in case you forget the formulas and how to actually do the problem. Okay?